Welcome again for your second class, that is physics for today, 15th September today's date. Now we'll have another session on physics. In the physics we were discussing last time a cell. In that cell, I'll just do a quick recap before I go to the next topic. It consists of two electrodes or the conductors, and it has the electrolytes. Okay, so here inside there is electrolyte, and these two are the electrodes, and these electrodes are also called the terminals, and from here you have the current is drawn. In the last class we had discussed three main topics which is coming out of the cell. The number one was EMF. EMF was the total potential difference of the complete circuit, that is outside the cell along the terminals and inside the cell, that is through the electrolyte. So that EMF was given by this symbol epsilon, and the formula for the EMF was work done in carrying the test charge in the complete circuit. Okay. Then we have discussed the second point, that was the terminal voltage. This is the first. The second was the terminal voltage. In the terminal voltage, it was the potential difference when the current is drawn. When the current is coming out, whatever the potential difference you have across these electrodes or in the external circuit outside the cell, that is called the terminal voltage. It was given by V. Then the third one we had discussed was the voltage drop. The voltage drop is given by small v, the voltage drop. And the voltage drop was nothing but it was also the potential difference across the electrolyte or through this electrolyte inside the cell. That means voltage drop was your small v, and you have the terminal voltage was here, and you have the EMF across the entire cell. So we have three potential difference. And we had also discussed that another term which was the internal resistance of a cell. In the internal resistance of a cell, we have discussed that as the resistance offered by the electrolyte inside the cell to the flow of the current. And that voltage drop, the formula was also given like this. See. So now we have got one important topic today I'm going to discuss. Based on this, you have to obtain the relationship between the EMF, the terminal voltage, and the voltage drop. So let us do that quickly. So for that I'll make a simple one circuit diagram. Okay, let us construct one circuit diagram or a conductor through which the current is flowing, and you have all the three types. Let us say this is a cell. We know that from the cell what is taken out, what is drawn is the source of the current. And suppose this is your internal resistance, this is the negative terminal and this is the positive terminal. Okay, then you have, let us say this is your terminal voltage. You have the outer circuit. This indicates that this is inside the cell, which is given as the inside the cell you have a small resistance and you have a voltage drop V across this electrolyte. For the entire cell you have this EMF. This EMF is the potential difference for the entire cell. Inside voltage drop, and this is outside, which is the terminal voltage, and this terminal voltage suppose is given by V. This resistance, this is a symbol for the resistance. Now what happens is, let a cell which has EMF of epsilon is used to send the current I It is used to send the current I in the external resistance or in the external circuit with the resistance R. Now we know that from the Ohm's law, we have used the formula for the Ohm's law. We have already understood that Ohm's law is V equals to IR. The same thing will be applied here. Now what will be the EMF for the entire cell? That is the potential difference, E. Now I, the current I is coming out from here, the same one current is coming out, but this is for the entire cell. If you observe that this is in the entire cell, how many now potential difference is there? How many resistance are there? There are two resistance in the electrode, internal resistance, and in the terminals, that is electrodes, external resistance. So these two resistance are in series. So these two resistance you have to add. So this is your equation 1. Ohm's law we have applied. Now if you look at this in the terminal voltage, the current is same I, and what is the resistance here in the outside? Capital R. And if you go that inside the cell in the electrolyte, what is the potential difference? Small v. What is the current flowing here? The same current I. And what is the resistance? Small r. That is internal resistance. So we have got these three relations. Okay, and we also know that EMF is the terminal voltage plus the voltage drop, or from here the voltage drop will be EMF minus the terminal voltage. Okay, now you substitute in the third equation this. So what is the, let us take the third equation from equation 3, V equals to I into R. Now you just got what is the value of V? EMF minus terminal voltage equals to I into R. And from here, what will be your internal resistance? R will be equals to EMF minus V upon I. This I will go down and it will be cross multiplied. So finally we have come to this relation, internal resistance equals to EMF minus terminal voltage upon I. Now see, these are the three equations we have got. In all this we have applied the concept of Ohm's law. This is for the entire cell, this is only for the external electrodes, and this is only for the internal electrolyte. And again we know that EMF is the sum of the terminal voltage outside and inside. So after solving this we got here, and we know that the current I from the second equation is V upon R. So what is the current I? It is V upon R. So this equation is the relationship between EMF, the terminal voltage, and the voltage drop. Okay, so we have to keep this in mind. Now we have another topic which is very, very simple, and it is also important from an exam's point of view. It has been asked in the exam also. On what factors does the internal resistance of a cell depends? On what factors does the internal resistance of a cell depend? That is small r. Basically there are 4 factors, but in the question it was asked only you have to write the 2 factors on which the internal resistance of a cell depends. So let me draw this quickly. This is electrodes and this is electrolyte. Internal resistance is here. The question is, on what factors does the internal resistance of a cell depends? internal resistance of a cell depends. It depends upon the four factors. First is it depends upon the surface area of the electrodes. Surface area of electrodes. See, this is the electrodes, the surface area. If you have a bigger plate, if the surface area is great, large, then you have the internal resistance will be less. Greater the surface area of the electrodes, lesser is the internal resistance. So it is inversely related, inversely proportional. Greater the surface area of the electrodes, lesser is the internal resistance. It is given in textbook, you can refer from there also. Second factor is it depends upon the distance between the electrodes. Now this is slightly, if the distance between the two electrodes is more will be the internal resistance. Okay, so that is directly proportional. So it depends upon the distance between the electrodes. Greater the distance, more the distance, greater is the internal resistance. Third factor is it depends upon the concentration or the nature of the electrolyte. It depends upon the nature or concentration of electrolyte. More the concentrate. If it is more concentrate, then what happens is the internal resistance will be less. Okay, greater the concentration of the electrolyte, greater will be internal resistance. Lesser the concentration, more ionic, it is more ionic, less concentration, diluted, and it will be less resistance. The final factor is that it depends on the temperature of the electrolyte. If the temperature of the electrolyte is more, then less will be the internal resistance. If the temperature of the electrolyte is less, then greater will be the internal resistance. That means it is also inversely proportional. So these factors are quite simple. You can go through it in the textbook and it is very, very simple to comprehend or to understand. Now, since we have talked about the resistance is very, very important topic. Resistance is basically it is the obstructions to the flow of the current. Internal resistance is the same thing, but it is happening inside the cell. Now, we have this resistors. This resistance can be also called the resistors. We can have more than one resistor and they can be combined. Okay, they can be combined, and with this combination of the resistance we can control the flow of the current. So that is the next topic, which is called the combination of the resistors or the resistances. Basically there are two types of the combination, the series combination and the parallel combination. So this we will be discussing in the next class, that is on Thursday. We have got in this section, that is the combination of the resistors, you have to make the diagrams. A lot of diagrams has to be done, and simple numericals are there, which is based on the formula of Ohm's law, V equals to IR. Okay, this much for today. Please study this topic regularly and do the home assignments. Thank you very much.